So we'll have one last example of a full-blown regression analysis. The following data represents X, boat sales, and Y, boat trailer sales from 1995 through 2000. Perform a full regression analysis on the relationship between the boat sales and the boat trailer sales. So, here we have the data of boat sales and boat trailer sales. If you're not familiar with the boat trailer, it's the one that we attach to a car so that we can carry a boat to different locations via land. And here is the year that corresponds to each. So, pause the video, and that will be for a long time, and try to perform a full simple linear regression analysis on our data. So, let's answer this one. We already know what is our x independent and what is our y dependent. It's given in the problem. So, we can now go to insert, the charts, then our scatter plot here. But as you can see, we had 3, so I was not able to select. Well, I need to select this 2 first. Please don't do what I just did. These are just here, that's not needed. So, now I selected what I need. We can now do our scatter plot here. I will not change the names anymore because it takes time. As you can see, our trend is kind of flat. It kinds of rises, but not that very high. So let's look at our trend line. So we go to this one and we click our trend line there. Let's just have what our trend looks like. So we format our trend line. There we go. So I just want to look at more. There you go. And then color black. So it will be more. It can be seen more and we can see it here. And when I go back to this one, I can already show my equation and my r squared. So there we go. And I'm just going to make this bigger, and there we go. And as we can see, we have our equation here. So, statistically, we can say that for the boat trailer sales, so I will just write trailer, the estimated trailer sales would be 0.6075 times the boat sales minus 184.71. As you might have noticed, it's minus. So, if we're going to interpret each of the coefficients individually, especially our b sub 0, our b sub 0 is negative 184.71. Meaning, if there is no boat sold, because our b sub 1, if there is no boat sold, meaning this is 0, then actually we have a loss. We don't have a gain, but we actually have a loss of $184.71,000. So that's why this is negative here. So now, let's see. It looks like a positive relationship, but we still need to see. So let's compute for our R. So we will already go to data, data analysis, select correlation, click OK, and now we shall select our data. I hope you're already familiar with the process. Output range, I'll just select it here, then we click OK. So now, if we're going to take a look, we have a positive relationship and it's 0.93. So our relationship is actually here positive, and very high correlation, or a very strong, very high or a very strong correlation. And with our r squared is equal to 0.8814, we can also say that 88.14% of the variation on the boat trailer sales is due to the boat sales. So 88.14% of the boat trailer sales is well affected, or the differences here is well affected by the boat sales. So now, we shall now do our hypothesis tests. So, I will write step 1 here, and as usual, our HO is that B sub 1 is equal to 0, and our HA is that B sub 1 is not equal to 0. So, shall now go to data analysis, regression, and I hope we're already familiar. We input Y first, this one. Then we input X, both sales. And then we just put our output range here. There we go. And then we click OK. So it's down below. So I need to clear this ones out. So here we have our step 1 here. So we have our steps 2 and 3. And our step 4 now. Step 4. Oops, let me clear this one out. There we go. So we need to look at our p-value, which is this one. Our p-value is approximately equal to 0.01 because that's 0.005. So round off 0.001. And obviously, compared to our alpha of 0.05, that is less than 0.05. Therefore, we shall reject our HO, and I'll just make it short. We have a significant relationship between the boat trailer sales and the boat sales. So again, that's how we do a full, simple, linear regression analysis.